Okay, so for this last video, we are going to be using trig applications or trig to solve application problems. We've got two of these. Ultimately, guys, what I'm going to tell you is I'm still going to use my calculator here to do this as opposed to taking you to Desmos because I think it's a little bit faster and this might take a little longer. The key, the thing that you have to do, no matter what, is draw a picture. If you don't draw a picture, you will not be able to do this work. And I mean that with every part of me. There is absolutely no way that you can keep this crap in your head and try to figure out what it's going to be. And if you try to do it to challenge yourself, that's great. Don't do it when you're being graded on a test. It's kind of dumb to try to keep this stuff in your head because drawing it means you know that you're dealing with the right side at the right time. Okay, so with that being said, boy flying a kite lets out 150 feet of string, making an angle of 64 degrees with the ground. So we got ground, string, and 150 feet of string. Okay, so here's where the boy is. Here's the ground. This goes up like this, 64 degrees with the ground. This is 150 feet. And it says the string forms a straight line. How high is the kite above the ground? So right up here, we're looking at our kite going off in the distance. You don't have to draw the kite, but this is where it's at. And we're trying to find the height above the ground. So that is, if we drop this straight down to the ground, that hits at a right angle. We are trying to find H. Okay, so you see what we're looking at here. We have an angle here that's 64 degrees with the ground. We have a right angle with the ground. This is 150. So from the 64, now we set up our trig operation. This H is opposite, and I'm going to do this for height because H also stood for hypotenuse. I don't want you to get messed up with that. So this is the opposite side. The 150 is your hypotenuse. So if we're going to be dealing with opposite and hypotenuse, we will be talking about the sine. Sine of the angle 64 is equal to the opposite, which we don't know, H, over the hypotenuse, which is 150. Okay, now to solve this, we got to get rid of our 150 by multiplying it on both sides. This will cancel out, and we get that H is equal to 150 times the sine of 64 degrees. Ready to plug into the calculator, and because we're talking about distance, this will be in terms of feet. So 150 times the sine of 64 is going to be 134.819 or 134.82 feet is equal to the height. So that's how we go about doing stuff like this. We're just finding one of them. You draw the triangle, you find out what your unknown is, you figure out which trig function is applied, and then you do that. And this one was pretty easy because they did talk about it making an angle with the ground and a kite being above. When we start to talk about things like angles of elevation and angles of depression, I do want to make sure that you're thinking a little bit more about what this looks like. This one says angle of depression. So just right now, top of a vertical cliff, 40 meters high. All right, here's our cliff. Great. This is where you are. This is 40 meters high. The angle of depression of an object that's level with the base of the cliff, so this will be our base, is 34 degrees. Okay, so this is our horizontal. If it's an angle of depression, that means from this down to where this is down here, that is our angle of depression. Now, I'm labeling it so you can see it. This isn't something that you're going to need to do very often, but we get there. This angle here is 34 degrees. How far is the object from the base of the cliff? So this is our object. Here, we'll make it like a little package. There we go. There's a package waiting for you. Look at that. There's a package. Hooray. So we're looking from here. Angle of depression is 34 degrees. The height is 40 meters. We want to know what this base length is, which is X, to see what the distance is from here. Now, here's one thing that I would do. I would remember about the fact that this 34 degrees, because horizontal is going to be parallel with our base that we have here, this and this are alternate interior angles. So this will also be 34 degrees. It's helpful to label that within the triangle that we're looking at. We could drop this here and label this at 40 meters as well, but it doesn't really matter if we do that. So here's what we're going to do. By the way, that means that my class is about to get started. To solve this then, I'm going to set up a trig with this and this. This is the opposite, this is the adjacent, so we're going to use tangent. The tangent of 34 degrees is going to equal the opposite, which is 40, over the adjacent, which is X. Now, again, We've got our little algebra magic where these trade places, and we know that x is going to equal 40 over the tangent of 34. Again, if you want to see that algebra magic, look back at the video that says finding unknown sides using trig. I'm going to be using the calculator here to say 40 divided by the tangent of 34. And that is going to give me 59.3 meters away. It's 302, but I think the 0.3 is fine. So 59.3 meters. That's how we set up things with angles of depression. Angles of elevation just means, like we did the last one, going from the ground and up. So that would be helpful as well. So hopefully that is enough for you. It'll be good to give you some practice, and good luck.